All right, today we're looking at function families. Function families. We have 6 main families we're going to be looking at and studying in this Algebra 2 class. Here's the pictures of the graphs of each one. We're going to have to know these graphs and be able to recognize them and name them. This one right here, I'm going to put the name right here. This is linear. L-I-N-E, line. It makes a line, but spell it linear like this right here. It's just a straight line. This one right here, absolute value. This one right here, cubic. This is cubic. You see how it curves up through here and then around and then curves back up. This one we've studied a little bit. Quadratic. This one right here is square root. And then this one right here is reciprocal. Or can also be called rational. Okay, these are the 6 functions families that we're going to study. We also need to know what the equation is. It looks like so, like this right here, linear. That's what f of x equals just plain x. And what x is doing is what makes these different graphs. See here, we just have a plain x by itself. Now we can have a multiplier, we can have add, subtract, but mainly x is just in there and it's not really getting anything done to it. Now right here, this is the absolute value of x, when x is in these absolute value bars. And just like I said about linear, we can have multipliers, we can have add, subtracts, but the main thing is x is in the absolute value bars. Cubic, this one, f of x, is x to the 3rd power. So again, we can have multipliers, we can have add, subtract, or whatever, but the main thing is x is being to the 3rd power. This one right here, quadratic, this is when x is squared. This is a square root function, so guess what? It's the square root of x. And then this one, the reciprocal function, we can have add, subtracts, multiplies, divides, but the main thing here is we're dividing by x. So something divided by x. And again, we get multipliers and add, subtracts and stuff, but the main thing is we're dividing by x. And that's what makes these. So we need to study this page right here. Maybe you could take a picture of it. And I wish it could all fit on there. Maybe I could zoom it out just a little bit. And maybe you could take a screenshot of just this right here and study this. Okay. Now the main thing we're going to look at in these functions, once we know the names and the function notation and everything, is the domain and range. Now you see these are linear. Both of these are linear. This one, as you go from left to right, it's going downhill. Okay, so this has negative slope, or it's decreasing. This one's going uphill as you go from left to right. It's going uphill. This is increasing or has positive slope. But when you look at your domain and look at your range, on the domain here, from left to right, the furthest it goes to the left, well, this thing goes forever to the left, and as it goes down, it goes forever. So this is negative infinity to positive infinity. My domain here. Every value of x is realized. As far as range, as this thing goes to the right here, it's going down forever. And as it goes to the left, it goes up forever. So same thing on the range here. Now, if you have this positive slope one, well, guess what? My domain is the same thing. My range, you guessed it, same thing. All right, so what that tells us here, when we have a line, any linear function, my domain and range is going to be positive infinity, negative infinity. My domain and range both, unless there's two ways it could not be. And that's if you have a line that goes straight up and down, because it doesn't go left and right any. So it means the domain would just be that one value. Okay, the range would go negative infinity to positive infinity. Now, if you have a line that's horizontal like this, it goes to the left and right forever, so the domain would be negative infinity to positive infinity, but it has no up and down, which means it would have just one value for range. So in these two cases right here, that's the only time your linear equation will not have this domain and range. Okay? Now let's look at the next one. This is absolute values. Absolute values form this V. The reason is because when you do the absolute value of x, as it's negative, it increases positive, and as it's positive, it increases positive, so it bounces. So like you can see right here at this vertex where it bounces. Okay, now as I look at my domain here, my domain is negative infinity to positive infinity, because this thing goes to the left forever. See, as it goes up, it's going over. And as it goes up on this side, it's going to the right forever. So that's my domain right there. But my range is different on each absolute value graph. You got to have, when you do your interval, this is low and this is high. All right, my lowest value on this for the range is right here, -2, and it is included, so I'm going to put a bracket. The highest value, well, it goes up forever. So that would be my range. Okay, so if it's going up like this one, you got a low value and you got infinity. But my domain will always be this. So on this one here, my domain, negative infinity to positive infinity. But my range, all right, the furthest down it goes down to negative infinity. The furthest up it goes is right here, -3, and it does include it, so put a bracket. So that's how your domain and range will be. Your domains will always be this on absolute values, but my ranges up and down, it only can go up so high, or it can only go down so high, so low. Okay, and that's absolute values. Now, same thing goes for quadratics. My domain, every time, negative infinity to positive infinity. That's my domain every time on quadratics. Because as this thing goes up to the left, it's going to the left forever. And as this thing goes up on the right, it goes to the right forever. Same thing if it's concave down. As it goes down, it's going to the left. As it goes down here, it's going to the right. All right, so my domain's that every time. Now my range, that depends on the function. My range is different on these. So on this one, the furthest down it goes is right there, -6, and it does include it. The furthest up it goes is infinity. So that'd be my range. When it's concave down like this, the furthest down it goes is negative infinity. The furthest up it goes is right there, 4. And you do include it. So that's domain and range on quadratics. What about square root functions? All right, we see square root functions here, looking a little differently. All right, so here's my domain. Well, now on this, there's a starting point. So see all these values over here, there's no x values over there. So it starts right here at 0. So I'm gonna put a bracket here. Like it starts at 0 and it goes this way forever. So that'd be my domain. What's my range? Well, my range is up and down. Well, the furthest down it goes is right here, and that's 0. And we do include it. The furthest up it goes, well, this thing goes up forever, so it'd be infinity on it too. Okay, but this thing could move around. See, like, what if it was here? What if that was my square root function? Then my domain would be starting here at 2, and it goes all the way to infinity. And my range, well, it starts right here at -2, and it goes up forever. So that'd be my domain and range. This one, my domain starts here at 0. We do include it, and it goes that way forever. My range, going up and down, well, it goes down forever, so it'd be negative infinity, but the highest value goes up is 0. And so that'd be my range here. Now, sometimes you might have one here, let's do this. let's have one like right here, and it's going this way. Okay, so as you do your domain left and right, it goes that way forever, so it goes to negative infinity. But the furthest to the right it goes is right here at -2. See, it goes right here to -2. It goes that way forever, but it stops right here at -2. My range, well, going up and down, it starts right here at 3, and it goes up forever. So that'd be my range. Okay. Now, this one here's the cubic function. On the cubic function, remember, x is to the 3rd power. So if you look at your domain and your range, my domain, as this thing's going down this way, it goes to the left forever, and as it goes up here, it goes to the right forever. So there's my domain. My range, it goes down forever and it goes up forever. So you will find on cubic, this is always going to be your domain and range. Always. Okay. Now, lastly, we've got the reciprocal function or the rational function. Now, it doesn't take you long to realize that this is in 2 parts. This has 2 parts, which means we have to do our domain and our range in 2 parts. So as I do this part right here, my domain, okay, you can see as this thing goes that way, it goes to the left forever. But as it goes to the right, it has this little line right here. Now this dotted line is not part of the graph. It's called an asymptote. Those dotted lines are called asymptotes. And what happens is this thing gets towards this asymptote and it can't touch the asymptote, so it starts hugging it, and it never does cross it. So this part goes to negative infinity, and it goes to this dotted line right here, which is -3, and it will not cross it, so it's a parenthesis. Then we do a little union thing for this part. All right, this part, the furthest to the left it goes is the -3. The furthest to the right it goes, well, this thing goes forever. And so that's what your typical domain would look like for a rational function like this. Because you have this value right here for x that you can't have. So you got to take it out. So see, -3, this asymptote here, it does not touch. So it approaches it on this side, and it approaches it on that side, but it does not equal it. So we have to do this. Here's the first part, here's the second part, and we union it together with this little u. Okay, now as far as the range, we've got 2 parts. We're going to have 2 parts on it too. So now there's a range. See, this part right here, it goes down forever. So it goes from negative infinity all the way up to this value right here on this asymptote that's going horizontal. That's 1. And then for this part, we have to do our union thing. And this part over here, it starts at 1, and it goes all the way up to positive infinity. And so that'd be my range. Okay. Now what you could do is you just realize that, hey, I've got this vertical asymptote at -3, so I've got to take that value out. So that's what I'm doing here. I'm taking that value out of the domain. And I have this horizontal asymptote at 1, which means I have to take that out of the range. All right, so that's a little bit about function families. If you have any questions, let me know. Just holler at me anytime. Have a good rest of the day.